We often look out into the galaxy and wonder where all the civilizations are, but could it be that we don't see them because they've all chosen to exist in fortress star systems surrounded by despoiled deserts of their own making? When we look up the night sky and see thousands of stars, it naturally raises the question of if any of those might be home to other peoples, distant kindred of ours, spiritually if not genetically. When we found out the galaxy is so much bigger than even what we see, and itself is but a pinprick in the universe, it's natural to ask the question of why we don't see other alien civilizations. This is what we call the Fermi Paradox, the seeming contradiction between our observations of how big and ancient our universe is, how full of life our planet is, and how absent the rest of the universe seems to be of that life. The universe is throwing the ultimate silent party, and Earth didn't get the memo. Either that, or our invitation got lost in the cosmic mail. One option that we explored a couple months back is that life is quite common, and that it just rarely gets very complex. Only for a fraction of the time Earth has had life on it has it had any real plants or animals. So perhaps we are an anomaly, and the universe is full of worlds that are full of slime and algae and not much else. Of course, this suggests that in the grand scheme of things, cosmic evolution might have a penchant for the simple life over the drama of higher intelligence. Or even that higher intelligence and consciousness is temporary or self-deleting, and we'll explore the option in more detail in our Fermi Paradox Time Bombs episode next month. Another option that we explored last month were various Chronos scenarios, where the homeworld of species either chooses not to colonize space, or does, but like Chronos of mythology, comes to view its children as a dangerous threat and consumes them or wipes them out. The hypothesis we'll be looking at today draws on both, as well as the better-known zoo hypothesis line of reasoning, to explain why we can even look up at the night sky and see any stars at all, rather than Dyson swarms, or overwhelmingly loud broadcast of colonized systems, or some fake zoo-like reality, while offering us the possibility that intelligent alien life may be modestly common and not inevitably prone to self-destruction. This is the Interdiction Hypothesis, the idea that civilizations only expand so far and leave a buffer space between each other, and we'll examine both the basic theory and what it looks like in the more grim perspective of the Chronos scenarios. As we'll see, it can get rather grim indeed. As usual for our Fermi Paradox discussions, there's a lot to discuss, so we'll be here for a bit, and you might want to grab a drink and a snack, and don't forget to hit those like and subscribe buttons. Now, basic interdiction hypothesis is a bit like zoo hypothesis, but with a flavor of mutual self-quarantine, and is the notion that spacefaring civilizations do not expand quickly and slam into each other because they agree to large buffer zones. In the absence of FTL, fast light travel or communication, they can't do much to contain or de-escalate any border crisis, because their mutual border might be a few hundred light years away, and they need that long to even hear about some dispute. By which time it might have broken out into a multi-system war, and one where neighbors might often feel obliged to initiate preemptive strikes because all of their intel is constantly vague and out of date. In a universe without FTL, social distancing takes on a whole new meaning. Civilizations might maintain buffer zones not because they're antisocial, but because their messages take too long to RSVP. So they don't want their colonies anywhere near each other, and they want large volumes of empty space between them as a buffer, so that if someone decides to colonize something anyway, they have lots of time to react, because there might be hundreds or even thousands of empty systems in that neutral zone, and any rogue elements that colonize into there are still unlikely to be seen as a big threat to the status quo that requires immediate and decisive action. A Star Trek series based on the interdiction hypothesis would start an episode with Space, the Final Frontier, where civilizations say, good fences make good neighbors, and by fences we mean buffer zones of empty star systems. Somehow it doesn't quite have the same ring to it. Nonetheless, we see a neutral zone between the Federation and Romulans in Star Trek, and the reasoning discussed for it on the show is plausible. Those neutral volumes might still have large numbers of civilizations inside them, potentially many trillions of people, but their small and quiet groups try not to agitate the bigger powers who they originated from many centuries or millennia ago, so as not to encourage some sort of policing action, or extermination protocol for that matter. In that context, those living in those buffer zones might pass under the radar for the Fermi Paradox, so if we happen to live in such a buffer region ourselves, we would not necessarily know it. The first and last we might know about it is when the Vogons show up to let us know we failed to file a valid permit for occupation and they were here to deconstruct us. When it comes to nearby alien splinter civilizations or their parent civilization not talking to us, from a Fermi Paradox perspective, all we need is something plausible because it doesn't have to be a universe-wide policy, just the one true in our local bubble of space between the two or more major polities bordering it. Thus, even if this was a rarity and most other alien empires crushed right up against each other, so long as it's not super uncommon, it could explain the universe we see. Or so that reasoning goes. We'll return to that in a bit to question how sound it is. This is an important consideration because of what we call exclusivity and non-exclusivity under the Fermi Paradox. And that's where we have solutions that assume everybody acts in a certain way, and otherwise the proposed solution does not work. And it is the weakest point of most Fermi Paradox solutions I've encountered. If a given behavior isn't exclusive to spacefaring races, it's probably not a good one, and my default example is to point out that since the space race was between the capitalist US and the communist USSR, and both clearly made impressive successes in that race, while one may be better at space than the other, we cannot assume space travel is exclusively the province of civilizations which are capitalist or communist, or neither. Alternatively, you can make the argument that space travel is exclusive to civilizations that understand rocket science, since it would be hard to have a spacefaring civilization without that skill, and thus is always exclusive to a decent understanding of mathematics and physics, which makes them easier to communicate with, since they and we would both know that and presumably attempt to embed that in our hello signals or expect that to be the case. So we should be able to talk to them, at least about science and math. Of course, we could encounter a spaceborne cow-like species as well, which might make communication hard and not particularly valuable, where the most useful interaction comes down to them ruminating about where to get the best tasting tholins in the Kuiper Belt. So while it is good to have rational assumptions, it always pays to remember the universe is large enough to have a good laugh at us and our assumptions too. It's not that an alien isn't likely to know the value of the speed of light in a vacuum, or Planck's constant, or pi or powers of 2 or 10. It's that they might not have thought it a good basis for composing a Rosetta Stone or cracking a language. As to why non-cow aliens don't talk to us, many options are possible. Maybe they're just not that into us, or they take one look at our internet and decided we're already too weird to handle. One that we'll get back to later is that about all they have in common with us is math and science, and they frankly find us disgusting and every other alien they've met too, and vice versa. They're not hostile, they just don't think we'll get along, and have good reason to believe that. And since there's probably a finite amount of math and science applicable to this universe, it's quite likely that even that point of mutual interest doesn't imply much conversation back and forth. Or maybe they don't talk to other low-tech races because they've agreed not to because they don't want their potential rivals or enemies poisoning the primitives' minds about them, and they think conflict is best resolved by avoidance. And if we are in such a buffer zone, then occasional minimal violations by rogue actors or the alien police force chasing them may be the source of apparent UFO sightings on Earth. While I'm quite skeptical about those in general, they can't be casually dismissed either, and not too many solutions to the Fermi Paradox handle them turning out to be true very well. This one does. The philosophy is stay away from aliens. You can never wipe them all out. Everyone will know if you try and reply in kind. You are always surrounded by potential enemies who have every motivation to attack you back if you try it. You will end up warring constantly at the galactic scale. And even if you win those, it just means that when you expand out to claim that new territory, you add way more border that you can't hope to realistically guard, and which territory has fresh new enemies who have every reason to view you with hostility. Plus the places behind you, your divergent kindred, might represent a threat now too, enemies on every side. Even if you weren't the aggressor, they may not believe you, especially if it has happened repeatedly. And again, there's also the reality that all those colonies of yours, separated by many centuries or even millennia of communication time, aren't really you anymore, and potentially are an enemy waiting to happen, and one that does not benefit you by its existence either. You're probably not getting taxes or resources from some colony 1,000 light years away, and yet you might be getting doomsday weapons, rogue AI, or hegemonizing swarms from them when they mess up, or getting drawn into a war they started with some other civilization that now doesn't see the nuanced differences between your troublesome colony and you and keeps on attacking you. So it's easier to expand to an agreed on size, leaving buffers, and get along with minimal contact. Everyone agrees to keep themselves pretty small, so nobody has a motive or ability to go to war. And since their own descendants are likely to be pretty alien if divorced far enough by space and time, they may see no reason to go butt heads with actual aliens just to make room for distant mutant cousins. Indeed, they may just prefer not to have any cousins who are very distant and mutant, so may not need much encouragement to keep their civilization to a relatively small and contained sphere. Interdiction does not assume any particular alien motivation besides caution, which doesn't necessarily violate exclusivity. We can assume that, like curiosity, caution is a trait probably shared by all technological civilizations, and if not, then probably a very common one with a few weird exceptions. There's also good reason to enforce that buffer to avoid getting drawn into fights, which at least in our history are way more common when you're staring at each other from 2 feet away. When your borders touch with no real buffer, you're essentially never further away from a conflict than your most provocative citizen or your worst day. It's easier to enforce it with all that buffer space rather than direct borders. That buffer space gives you a bit of time to come to your senses and retrieve weapons you fired at your nemesis in a hot-headed moment, all while firmly telling their ambassador nothing to see here, just stay on your side of the line. This is not an instant fix for all alien diplomatic problems. You still have the issue of newly emerged spacefarers like us getting angry nobody gave them technology and resenting they were left to face endless disasters when a few easy bits of help would save untoward millions. When pressed, the aliens might reply, "Actually, we're not really so high-minded to believe that interfering with primitives is beneath us, even to save them from asteroid strikes or plagues." They then wave their prehensile eye-limbs in a sign of embarrassment, saying, "Rather, you see, we agreed to this treaty. It's been around for a very long time, even before we entered the galactic stage, and even if we didn't think it was a good idea to keep it, we don't want to suffer the consequences of violating it. If you feel otherwise, you go right ahead, and if you're still around and feel that way in a few more millennia, we'll send you an apology letter." We might discover the treaty is self-enforcing because it's not Empire A and Empire B, it's 2 or more meta-civilization blobs that may themselves be composed of hundreds of different multi-planetary empires. So you might be as likely to get a forceful response from your colonizing cousins than the aliens on the other side of that buffer zone. The other big objection to interdiction tends to be that it is implying we can't all just get along and be friends, which flies in the face of our Star Trek ideals of seeking out new civilizations and getting to know them and be made better for it. An objective look at the risk posed in the various TV series actually makes the case for not boldly going because of how badly that notion can go wrong. Real life isn't a TV drama, and inviting yourself into a battlefield or isolationist advanced civilization will probably get you explosively uninvited. The captain won't save the day, especially as his disassociated, cooling atoms and those of the ship and crew are making a tiny expanding volume of their own, and now you've got some diplomatic headaches and explaining to do. So the Trek concept isn't the best objection to the interdiction concept, but rubs some folks the wrong way because they figure we ought to be able to talk to anyone and be friends with everyone. That's not to say that interdiction requires complete isolation. You can chat a bit, have regular communiques between your diplomats and anthropologists, or scientists and mathematicians, just that it's kept formal, controlled, distant, and minimal. Realistically, getting along and tolerating other cultures is one of our cultural ideals that perhaps isn't necessarily too grounded in reality. Humans share common culture and biology, but still have a lot of cultural traits and traditions that infuriate or disgust each other. And that's not necessarily wrong, An example I often use for this is the idea that we probably do not want to go to war with an alien civilization just because they have some very different views on the value of life than we do. Familiarity breeds contempt, and the more familiar we become in close proximity to them, the less we will tolerate their morals, traditions, habits, and ideals that jar with our own. Consider that most countries with political divides of, say, two parties often agree with each other on more points than they would a foreign party, and yet often have immense hostility for each other due to their proximity and regular interactions. This probably would only be made worse if that proximity remained, but the differences in views were sharper. Humans don't have many kids, so they are precious to us, and we consider that a virtue, so we expect aliens to have that view too. But maybe they give birth to large litters of children who rapidly grow to fertile age but not wisdom, and would double their population in under a year when left to their normal breeding rates, even ignoring that they would run out of arable land in mere years, far faster than they can invent better farming tech. If they basically had their kids hitting mental maturity closer to our age, but physical maturity in just a couple years, if they didn't control that growth, they will always have over 90% of their population in an infantile or juvenile state. That juvenile state might not be something they view as very cute either. Little kids are cute, but teenagers are competition. In that context, the aliens might have adopted a policy long before they had science and advanced medicine that amounts to weeding out everybody when they're kids, culling their own numbers to something manageable, and only keeping children exhibiting the best traits of whatever they consider desirable. They might even treat hunting down their children as a sport, as explored in Ian M. Banks' book The Algebraist, looking at the dwellers. That might be a bedrock of their society and ethics, so they would be horrified if you suggested changing it up using birth control. They don't view it as wrong to meticulously cull 90% of their children. After all, it allows them to select the best individuals to serve their society, so they wouldn't see any point in switching to some new medical method, one that might carry health and societal risks to use. In all other matters, they may be admirable and entirely humane, for a relative extension of that term. For my part, I find that culling notion abominable, and obviously wrote it with that in mind to illustrate the idea that we can't always be everybody's good friend simply by getting to know them better. Your mileage may vary, but by default this strikes me as a civilization we don't really want to be close neighbors with. We don't want to be their enemies, and maybe we can be mutually beneficial in sending science and knowledge between us, but not much is gained by proximity, where we might have a neighboring colony that just couldn't stand seeing that policy being enacted on its doorstep, and the next thing you know, a galactic war is going on over it. Or maybe they declare it on us for some behavior they find atrocious that we don't even think about. An extra century of travel time between them and us lets cooler heads prevail, discouraging crusades, and gives the originating civilization time to send out official condemnation or even chase that crusading fleet down and force it to turn around or be fired on. Perhaps you do decide that you can't share the universe with these people and join that fleet with reinforcements, but at least it was a decision made with time and reason by your civilization, not a handful of hotheads living on the border who may have reacted to unintentional provocation. Now, the reason I don't tend to think Interdiction Hypothesis is a good Fermi Paradox solution normally is because the easiest way to enforce this policy would be to loudly broadcast that an interdiction policy is in force to everyone nearby as soon as they could hear and comprehend it. There should be some galactic beacons up proclaiming the policy, and we should be able to hear them, along with long messages of self-justification from this or that empire proclaiming how awesome they are. But don't you dare go there to find out for yourselves, or they'll show you how they deal with uninvited guests. Given how closely this mimics the behaviors of critters marking territory and trumpeting about themselves, I find this behavior much more believable than complete silence, especially given that many might choose silence and others not, and still have tons of such communications, while everyone deciding to be silent seems dubious. We could rebut by saying such beacons do exist, but they're in some high-tech FTL communication methods, or possibly a more subtle one we'll get to in a bit. But as we were discussing in the Galactic Beacons Nebula exclusive last month, when it comes to warnings, sooner is better. If you don't want folks producing dangerous AI, you send that message out in a fashion they can hear before they have AI. So too, if you want to have a system that people mostly voluntarily obey, inform them of it before it spoils their dreams. We've been imagining interstellar colonization for over a century now, and hanging out with cool aliens on strange new worlds, and that means we are going to object if tomorrow we get a beacon saying no, we can't do that. Trust me, I've spent years raining on people's favorite sci-fi concepts, and they rarely thank me for it, and those who do usually phrase it as a thanks for doing it in a detailed and polite fashion compared to others. They're not really thanking me for wrecking their daydream. It's a lot easier to change people's minds, and with less resentment, if you establish a rule from the outset. So you might as well broadcast that signal to be heard as soon as they invent all those radio telescopes that will let them see how huge and ancient the universe is. That way they think you're being really generous when you offer them 1,000,000 planets, which sounds like a lot, but it is less than 1,000,000th of the planets in this galaxy, and probably only a bubble of a few hundred light years out from Earth. That's the basic theory of interdiction and its major strengths and weaknesses, but let's expand the discussion in light of the Chronos scenarios from last month and some of the conversation on the Fermi Paradox and hypothetical aliens we've had since our 3-hour compendium of Fermi Paradox solutions last year. If you're a channel regular, then you probably know my preferred solution to the Fermi Paradox, which is to say, I don't think any of the solutions seem to quite fit the evidence. The one with the least flaws to me is the idea that intelligent life is rare, and those that get spacefaring technology are very rare, either because life overall is rare or because it doesn't get smart often, or does but doesn't get technology. This is a variation of the wider camp known as rare Earth, that Earth is not a boring and mundane example, but rather a remarkable lottery winner in some way or combination of ways. We've discussed all those options before in our Great Filters series. I don't view the zoo hypothesis and simulation hypothesis scenarios as falsifiable. A hypothesis is scientifically credible only if it is inherently falsifiable. This means that the hypothesis must be capable of being tested and proven wrong, which you cannot do for many of the hypotheses we discuss, albeit they may still be right. But if something isn't falsifiable, or can only be so by acts outside our control, like the simulators or zookeepers choosing to let us see the matrix, then we were limited to just laying out some discussion and logical reasoning for or against. Instead, my go-to for rare Earth being wrong is if something kicks in to make an ever-expanding civilization sprawling over the entire galaxy or even beyond just not function. As long as a civilization isn't expanding out until it runs into other civilizations, either peacefully or not, there's no real problem with us not seeing aliens just so long as they're not insanely common. So any conditions that prevent that represent a plausible Fermi Paradox scenario. We generally call these late filters, things that interrupt that progression toward filling the universe up so thoroughly that you cannot miss signs of life. By default, the late filters are that we blow ourselves up before getting into space, or that we find space travel is impossible or at least impractical, and this was the opinion of Enrico Fermi, after whom the paradox is named. And the alternate solution I just described, that life inevitably will spread out if it can, is the viewpoint of Michael Hart, the biologist who coined the term Fermi Paradox in the 1970s. I don't tend to think of that self-destruction as being inevitable. Even if 9 out of 10 civilizations get wiped out, you still get a galaxy-sprawling civilization spread out from that survivor. I don't view interstellar travel as impossible or likely to be impractical either, even if your civilization needs to spend a century working itself up to send a new Colonial ship out, and even if half of those fail, and the successful ones need 10,000 years to grow enough to be willing and able to send out one of their own, you still get a civilization that's growing to spread over a whole galaxy in a relatively short period compared to the age of that galaxy. So for me, any solution in this late filter area has to explain why a civilization could have the technology to engage in space travel and still not spread out in a way that is self-perpetuating. And again, this doesn't require that every planet or civilization does it. Earth might cheerfully send expeditions to tens of thousands of stars within a couple light centuries of us, then decide it was done doing that, too much effort, took too much time to keep it interesting, too little gain in expanding, and the smattering of distant cousins that came back from those missions were very strange indeed, and not people you'd invite to a family gathering. However, that doesn't mean some colony of ours near the periphery doesn't grow up and continue that in 10 millennia or so. The tribes hanging around northeast Siberia did not write home to Africa to see if humanity should spread over the land bridge into the Americas. So one of the most common answers given for the Fermi Paradox is that civilizations just don't keep expanding, and the reason is that at a certain point this doesn't really benefit the homeworld anymore. And again, this is fine enough, but makes the mistake of assuming the homeworld is the part doing the expanding. In the absence of FTL, it's a safe bet anyone 1,000 light years from their homeworld isn't very connected to that place anymore. In any event, we have some decent reasons why expansion might grind out, and we've been examining those since the compendium. The Hermit Shoplifter hypothesis is one, and reasons that at a certain point, technology is so good that people don't need the complex supply chains of large civilizations. They've got something like Wikipedia and Star Trek replicators and emergency medical holograms going for them. While the more people they are around, the higher the danger one of those people is a murderous lunatic, who also has access to a replicator or advanced 3D printer for making doomsday devices with. So everybody packs up in small groups or singly and flees. If it turns out they're right, civilization eventually detonates wherever it establishes itself, so we don't see those big sprawling empires or Dyson swarms. The reverse position to that is the Chronos scenarios, where they start colonizing and where those colonies start showing signs of being an inevitable trouble, places where rebels can plot or rogue elements can whip up doomsday devices or rogue AI, far from regulatory control. So they either wipe them out while they're still overwhelmingly strong, or they wipe out any beyond a certain distance. Talk about taking the concept of tough love to a whole new interstellar level. Sorry kids, but it's for the greater good of the galaxy. Much as Kronos feared his children because he had usurped his own father, if that homeworld loses its fight against its dangerous offspring, those offspring now have evidence of how dangerous any of their colonies could be to them, and they know better than to wait. Where this merges into interdiction is that it contemplates a plausible in-between state. Your civilization believes, possibly through rigorous modeling and calculation, possibly by trial and bloody error, that it can safely run a civilization, say 100 light years in radius, and all its colonies are aware of this and entirely understand that they try to set themselves up as a new hub for an expanding sphere of their own. Their neighbors and the homeworld will crush them, and even if they succeed, they're just setting themselves up to be in the same position down the road, but now potentially surrounded by others who emulated them, and a very chaotic bunch of merged blobs of expansion. And this is what we expect anyway. It's not like in a no-FTL universe you get a peaceful eternal expansion of the Grand Old Republic back home. Every colony eventually flips its homeworld the bird, then gets it in turn from its own colonies. But we're not usually assuming those colonies are inevitably dangerous when we think about this in classic space opera science fiction terms, and as we saw in Chronos scenarios, we probably should be. And more importantly, we probably should assume all descendants and most spacefaring alien civilizations will be worried about that. Personally, I think they'll do it anyway, but that's where interdiction comes in as a sort of soft Chronos scenario. By this time, with colonies spreading over dozens of light years, if aliens are even a little common, we have spotted them, and since they are not expanding, have probably determined why, and it probably applies to us too. It would be very easy to imagine that if we spot a lot of civilizations around a light century across, and none bigger, that we would pay that heed, even in the absence of a beacon clarifying that this was some galactic rule. If you've got a few hundred interstellar colonies set up, and a number of your major and minor planets in your own system settled, odds are good you have run into at least some troubles with them, and maybe noted that the further away they are, the more trouble they tend to be. The ones on your doorstep and sharing your own house are trouble too, but you're kinda stuck with them. But the thing is, when someone says, hey, that's just part of growth, your children go their own way, people might reply back, especially in civilizations with medical life extension, no. A well-behaved colony on a distant planet 100 light years from here offers us nothing but another symbolic victory, one more plaque on the monument of settled stars. No new technology, no particularly original art or literature, no taxes or resources, too far to really trade or import from. One more occupied border to guard. That's our best case scenario from this colony, little to nothing. Our worst case scenario is they invade us or unleash some technological nightmare by accident or design, or we don't allow a colony there. Option 1, little to no gain. Option 2, possible self-destruction. Leave that planet be or send automated dumb harvesters there to pick the system clean. By doing that, we make it harder for any rogue element to establish a colony there in the future. I cannot say I agree with this line of reasoning and surely do not like it, but it is one I'd expect to hear and not one easily rebutted. And the universe does not care what I want to be true. If true, this results in self-quarantining, even without an explicit beacon from an alien warning you should or must quarantine. You just figure out what your safe bubble is, figure out how big your automated harvesting bubble is, and build inside the former while strip mining the latter. And you create a decent buffer state that way. And if anyone builds there, they are not in a very good position to resist you coming by to get them. They don't have the resources to get big and don't want to risk it. You send fleets of loyal ships out with crews on ice for the duration to scan around those picked over star systems and head home. As I mentioned earlier, there might be a subtle interdiction beacon. If we ever find a cluster of picked clean star systems, and given what we expect from the interdiction hypothesis, we should have a pretty good idea of what that represents. We should probably take this as a sign that we should be cautious about going any further, as old seafarers would say when they got to unexplored areas on the map, "There be dragons," except in this case there might actually be dragons. Spaceships are not covert vehicles either, so they're not setting off from your controlled space unnoticed. They are as subtle as a volcano erupting, and most easily seen from the rear where their engines are pointing, which makes them very easy to pursue and track. If one succeeds anyway, they aren't stopping till they're really far away, and presumably by the time they arrive somewhere safe, thousands of years away, and colonize and grow, they are quite likely to simply do exactly what everyone else is doing, growing to a set size and then banning further expansion. You get a lot of bubbles of civilization with wider, stripped out bubbles around them that are intentionally unappealing to anyone thinking of settling there. You surround your fortress oasis with a desert. And everybody else does too, and when someone decides they don't want to, the effect plays out naturally that way after various internal wars, where you might end up with a dozen smaller star kingdoms inside a slightly larger than average bubble, all with buffer spaces between, just buffers that might have once been settled systems and now are not, or are but are very decimated and kept that way. Though mind you, that might mean they still had billions of occupants in such a system. It's just far smaller than the typical system in the core worlds. So a few obvious questions come to mind, the first being why we don't see this. And the answer is that we wouldn't unless it was nearby. Basic interdiction hypothesis really should have beacons up warning people of the rules, and who are not inherently xenophobic. Some might be, others might not, so some should be chatty, but this variation we just described assumes we live in a grimmer reality, one where everybody has deduced by modeling or direct experience that their own colonies are a danger beyond a certain size, and that does not require that you actively dislike interacting with distant civilizations, but tends to set a stage where that's not preferable. You're not expecting distant civilizations to offer you anything beneficial. If they had been, you wouldn't have enacted that policy of drawing a maximum size on your own empire and pillaging the frontier to make sure it was useless to others, where you keep sending out automated miners until it's no longer even a break-even proposition to mine there just so nobody else can down the road. But that probably wouldn't include active starlifting, where we set a complex and massive device around a star to harvest metals from it magnetically, because that's not an operation anyone can accomplish fast or covertly, even at the interstellar scale, so if you see it getting set up, you go send a fleet over to have a not-so-quiet word with them. So a system someone did this ransacking to really wouldn't stand out much, especially to us now. We could easily have looked at pillaged systems, and since most of what we see are gas giants, not smaller exoplanets, we wouldn't notice that they'd gone through and removed all the low-hanging fruit and asteroids and just swing telescopes on all the bigger objects occasionally to make sure they are more or less the same. As we say about Dyson swarms or spheres, it's not that they are covert either. They are just as bright as the original star, just in some wavelength of infrared light instead of visible, and a good deal wider but dimmer. We could look at one tomorrow and not recognize it if we weren't paying attention, and while we can see stars thousands of light years away, most of the ones we look at are really big and bright giants, or ones acting exceptionally weird and anomalous in a way we lucked out and noticed. When we talk about not being able to miss Kardashev-scale civilizations like that, it's because we are assuming they keep on expanding till we cannot miss the giant, imperial blob of vanishing stars. But while we just semi-arbitrarily picked a light century as maximum radius for these interdiction bubbles, I'm not sure we'd see a civilization of that scale even in our own galaxy unless we lucked out, and that's assuming they were all Dyson swarms into that radius. In practice, I think you might only allow your core system to Dyson up, in favor of importing building material from your outer realm. A Dyson swarm with a good supply of raw materials can house 1 billion times what a planet can, so if you're keeping yourself as the only one, that lets you maintain a stranglehold over those colonies and also gives you a place to put people. You're not saying they can't live, instead that they need to do it in the inner system, and since they probably have fusion technology, they could just expand into their own Kuiper belt or Oort cloud for more elbow room. We also might not notice that they were slowly starlifting those neighboring systems for a billion-year stockpiling effort, and if they had to follow any sort of budget or limit for work, which seems likely, then it's hard to justify pumping your neighbor stars for spare fuel on a timeline vastly shorter than the natural lifetime of your own sun. If that was what it tended to look like, some Dyson swarm that was slowly mining around it and settling only its immediate vicinity, then that would be the sort of phenomena everybody would be able to easily spot once they knew what to look for, but that's very different than meaning we would spot it now, and we could potentially have 1,000 of these in our galaxy alone without it sticking out like a sore thumb to us even now. Does this modified version of interdiction work? Well, yes and no. I think it revises the idea of interdiction as a much more robust stance than the default premise, but it still has its flaws, and I'm sure there's others I haven't thought of either. Every Fermi Paradox solution I know of has some issues, most overtly fatal flaws too, but this doesn't seem to have any of those, at least that I've noticed. The biggest flaw is that it assumes a state of the universe that we cannot confirm yet, and which I hope isn't true either, that interstellar colonization is so clearly detrimental to civilizations that they all inevitably ban it beyond a certain radius and enforce it ruthlessly. The strength of this modified version is that they can do this, and there's a logical path to why they might, but it requires that the detrimental nature be so clear and unavoidable that everybody does this, including civilizations that are not particularly xenophobic or tyrannic. They are doing it to survive, not because they're selfish, and they leave places like us to ourselves because we're far from them and they think it inevitable we'll just build our own bubble like them and everyone else. But for that to be true, it has to mean it is at the point of being a mathematical and scientific certainty, psychohistorical inevitability, or so on. If it isn't, it falls apart, and I think it might anyway, since such civilizations still have every reason to watch for other civilizations popping up, new species or fled colonists setting up in a distant sector of the galaxy. And I feel that means they would know we are here, and I think we have a non-exclusivity issue at that point, because there was no overwhelming reason why a given interdiction bubble civilization, which we'll call an IBC, should be worried about sending messages to other IBCs or emerging ones far from them. I could believe most would think it pointless or turn pretty xenophobic, but I see nothing compelling an overwhelming majority to that attitude. So maybe 9 out of 10 IBCs don't send hellos or warnings or smugly schadenfreude-laden messages about how we too will have to become an IBC. That still leaves one of those 10 transmitting, and they may intermittently change their policy on it. Again, they have to be stable for millions of years for it to really work as a Fermi Paradox solution, so there's plenty of time for policy changes. They only get stuck in their bubble because they burned their proverbial ships at the shore by ransacking the shell of worlds right beyond that bubble. The prior pillaging might discourage a later attempt at expansion if they change their minds, but is overcomable, it's more that it discourages long enough for them to remember why they did this, which again we are assuming means because they reached a mathematical certainty that this was the wise path. Also, while I keep describing this as grim, they're not stuck inside some shell desperate for resources. They are an empire of hundreds or even thousands of systems with stockpiles to support themselves in luxury for trillions of years. It's grim because of their attitude, and why they have that attitude, not their actual standard of living. Nothing about an IBC setup particularly implies it's unavoidably some despotic dystopia, brutally murdering and pillaging its outlying colonies. If it's a mathematical necessity, it probably means everybody sane and rational agrees to abide by it, and interstellar colonization is not easy, so not something a small handful of crazy loons might do on their own. Even if they did, spaceships are not stealthy, and they would be easily detected and run down, and potentially without having to blow them up in favor of detaining them. No, to me it's bleak because it says the universe isn't a friendly place, and one where we can meet aliens or distant cousins and come to call them friends. And I grew up on the same sci-fi as everyone else, so it's not the reality I'd like to be true. And we'll explore the other scenario, lots of aliens and us trying to talk with them and live near them, in this weekend's Sci-Fi Sunday episode, Alien Embassies, as the opposite of today's case. But we don't get a vote on what's true or not. Probably. See our episode Reality Manipulation for alternatives. So it doesn't really matter if we like the Interdiction Hypothesis or Zoo Hypothesis or Simulation Hypothesis. They either are or aren't the case. Fortunately, while we can't rule interdiction out, I do not think the case for it is particularly overwhelming either. But what do you think? Is our destiny to be space hermits, waving at distant neighbors from the safety of our cosmic front porch? Or will we throw caution to the solar winds? Should we explore strange new worlds and make them our homes? Or is doing so just seeing them with potential future enemies? Let me know in the comments below. One of our themes was if civilizations will learn the right lessons as we head out into space, or if they'll have to repeat and relearn them a lot. And that's the thing to keep in mind as we head toward the end of another school year. If you or a loved one is about to head off for summer break, I strongly encourage you to have a plan for keeping all the knowledge fresh that was worked for so hard. Even just a handful of minutes every day can not only prevent backward steps, but let you keep moving forward. And that's something our friends at Brilliant understand all too well. Learning a little every day is one of the most important things you can do, both for personal and professional growth. Brilliant helps you build real knowledge in minutes a day, with fun lessons you can do whenever you have time. Learn through problem solving and doing, with hands-on interactive content that's fun, immersive, effective, and intuitive. Brilliant also has recently launched a ton of new content in data, all of which uses real-world data to train you to see trends and make better informed decisions. You can try everything Brilliant has to offer for free for a full 30 days. Just visit brilliant.org/IsaacArthur or click on the link in the description. You also get 20% off an annual premium subscription. That's it for today, but I hope you'll join us this weekend, Sunday, May 12th, for a look at the reverse case of interdiction, where civilizations sprawl near each other and set up alien embassies. After that, it's on to the idea of massive galactic empires and the enormous cosmic capitals that might oversee them. Then we'll look at a different kind of alien mind, one much closer to hand, such as animal brains, as we examine alternative intelligence, the other AI. Then we'll take an extended look at space freighters, what they'll carry and who will crew them, on Sunday, May 26th. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show by becoming a member here on YouTube or Patreon, or check out other ways to help at isaacarthur.net. You can also catch all of SFA's episodes early and ad-free on our streaming service Nebula, along with hours of bonus content like machine monitors at go.nebula.tv/isaacarthur. As always, thanks for watching and have a great week.